everyone, welcome to Eduverse of Read. So in previous video we have covered the basics of data preprocessing and some pandas functions. If you have not seen, the link is in the description. Today we are going to study data preprocessing methods. How we can preprocess the data before providing it to a model. For making the data ready for a machine learning model, we need to perform some tasks which are handling the missing values, encoding the data, splitting the data set into training and testing data set, and feature scaling. But in today's video, we are going to cover missing values and encoding part. Missing data can be a nightmare if not handled properly. Null values such as NA, that is not available values, none, or numpy NaN, which means not a number, are needed to be removed from our data set because they can significantly impact the quality and accuracy of our models. Missing values can introduce bias. If my dataset have some features which have missing values, will give less importance to those features. And also, if the model is trained on incomplete data, its ability to generalize the new unseen data may suffer, which means it may not predict correctly. So to tackle this problem, we have multiple strategies. The very first way is imputation. It means filling the missing values with mean, median, or mode. And the next method is very simple, that is deleting the rows which have null values. But be careful, if a lot of data is missing, you might lose important information. The next step is encoding the data. My machine cannot understand the linguistic or categorical values, so we have to convert them into numeric data type. So encoding is the process of converting categorical data into numbers so that the algorithm can process it. Since most of the machine learning models work on numeric data, encoding is essential. There are two types of encoding technique. One is label encoding, which means assigning unique number to each unique category. Let's take an example of feature color. We have three types of color. In encoding, we will give each color a unique number. Here we give red 0, blue 1 and green 2. But here you can see 0, 1, 2 are giving some order, but colors are not arranged in orders. So when we are going to use label encoding, we must use it for ordinal data. The another type of encoding is one-hot encoding. In this, we convert each category of our feature into a different column with indicating 1 as the presence of the category and 0 for absence. For example, we have our attribute colors in which we have three categories, that is red, blue and green. In one-hot encoding, new columns will be created for each color as it is shown. 100 will depict red color, 010 will depict blue color, and 001 will depict green color. One-hot encoding is used for nominal data which has no rankings. Now let's see some practical examples. Let's first delete the column unnamed. For this we will drop it using df.drop. In drop function we will put df.column index number 0 because it is at the first index. So we will remove it, giving access is equal to 1, so it can delete all the unnamed values from the table. And in place is equal to true. It depicts that we are saving the changes in the real data set. We can run the command by pressing shift plus enter so it can be executed. Now let's check whether it is deleted or not by writing df.columns that we have already studied in our pandas. We can see that the unnamed column is deleted. Now let's check which of the remaining columns we have from which we have to handle the missing values. These are the columns containing null values. To handle these, we have studied two methods. The first one was dropping the records that contain null values. So for that we can use drop NA. In this we can put the attributes or the hyperparameters according to our needs. You can check these from the help. First of all, I'm going to use how It shows how the algorithm is going to select the records which have null values. It contains any or all. Any means if there is any null value, delete the record. All says if all the values are null, then you have to delete the record. The next attribute is subset. In this, we are going to pass a list of the attributes or the features that contain null values. So only from these attributes the algorithm is going to delete the null values. And then is in place is equal to true. You can skip it if you want. Now let's check the shape of our data frame by using df.shape. You can see we are left with only 211 rows, means it has deleted some rows. Now let's print some of the records by using df.head. You can see the third number record is deleted. As you can see, it has null value in the work experience. The algorithm has deleted it. Now we think that drop NA is really a quick fix for messy data. But think again. It can silently weep out valuable information. It can also introduce serious bias, and moreover, it has reduced the size of our data set to something useless. So now what we can do instead, let me first comment this statement and show you which of the record was deleted. We have to run the upper statements first, then it will show it. So yes, so now we have 215 rows, and in this the head records, you can see the third record is back. So for this we will use SimpleImputer. SimpleImputer is a module that we need to import, but let me tell you another method also for handling the missing values. But before that, we must know which data type is to be handled with which method. So mainly we have two data types. One is numeric and other one is categorical, which is object. For handling object missing values, we can use it by using mode, that is the most frequent value. And for numeric data type, we can use mean, that is average, or median. The method other than SimpleImputer is writing a Python code which will use a function fillna, which is kind of an alternative of dropNA. So here we are writing a Python code in which we are writing a loop, that is for loop. It says for column in df.columns. It is df.column is what? A list. So column is the every element in the list of df.columns. In the next line we are writing if conditional statement. It will check for each element of the df.columns list. It will check whether the data type of the element column is object or not, and the column contains null value or not. Here and depicts that if both of the conditions are true, then only the column is to be proceeded. So here we are handling the missing values of object data type, which will be filled by most frequent value. So for that I have initialized a variable frequent. In the next line, we are printing the type of the frequent variable. You can skip it if you want. Next, we have to fill the null values. For that, we will use fillna function. Here we are writing df columns dot fillna bracket frequent dot index 0, because at the 0th index we are going to have the most frequent value. And when we run this code, we are going to get a warning. This is because of in place is equal to true. If you again run it, now let's check whether the attributes of object data type still have null values. And boom, they're all gone. They're all filled. Specialization, degree underscore T, maybe gender also. The null values here are 0, 0, 0. Similarly, we are writing the code for handling the missing values in the numeric data type attributes. So for column in df.columns, if df columns is not equal to object data type, which means it can be numeric, int or float, and df columns dot is null dot sum means it contains null values. Then we have a variable mean which is initialized by df columns dot mean. Mean is the function which will calculate the average of all the values, and then we will fill that average value in the null values. So for that we are writing df column dot fill na bracket mean, and when we run it we are having error. So we have missed dot data type and the if condition, that is df column dot data type is not equal to object. So when we run it, it is executed, and now let's check whether the numeric data types are filled or not, the missing values are filled or not, by using df dot is null dot sum. So yes, we are getting all the zeros, means all the null values are handled. So this was all about loops and conditions, but we can also use functional approach by using sklearn. Sklearn is a library by Scikit that we need to import first. But as we have handled all these things, let me first comment all these programs by selecting all this program, that code, and pressing Ctrl plus slash. It will comment all the code that you have selected. So when we run it, the upper code and the lower part, that is finding the null values, it will show that all the missing values are packed. Okay, so now we are going to use SimpleImputer. For that we are importing SimpleImputer from sklearn.impute import SimpleImputer. SimpleImputer is a class from sklearn library. So we are not importing the whole library, we are importing just a class. Also we are going to import numpy as np. If you have imported it already, then you can skip this part. Next we are going to initialize an instance named imputer. This is a SimpleImputer instance with strategy mean, because it is going to calculate mean and going to handle the attributes which have numeric data type, either it is int or float. Here missing values is a parameter that tells the function what value it should consider as missing in the dataset. Here we are giving it as numpy nan. Imputer is kind of a model which is going to find mean for our dataset with the help of the fit function. Now what fit function will do? It will look at the data, find the missing values, and figure out what values we should use to fill in the null values. Since we are going to handle our missing values with mean, so here in the fit function I am passing the attributes having data type numeric, either it can be int or float. So namely our attributes are going to be degree underscore p, etest underscore p, mba underscore p, and salary. So now as we have trained our model using fit function, now we are going to transform the null values with the mean. For that I have selected the same attributes or columns in which I am going to perform the transformation. With the very simple function imputer.transform, I am going to transform the null values with the mean. So after executing the code, let's check whether the null values are actually handled or not. With df dot is null dot sum, and I see all the attributes having numeric data type are handled beautifully. Now let's do the same thing for the object data type attributes. Now let's copy the model and paste the same. Now what we have to do is the strategy is going to be not mean but most frequent, most underscore frequent, and the attributes are going to be the attributes having object data type, which is going to be specialization and work experience. Copy paste the same thing in the transform statement also. Execute the code and check the null values again with the statement df dot is null, and boom, all of the missing values, either numeric or object, are handled beautifully again. No need to write such long code, just with simple imputer, fit, and transform, our missing values are handled. Let's do the encoding part in the next video. See you there.